All right, I would say we get started. It's noon.
Okay.
And welcome to the next Carolina GIS coffee break. My name's Bernie. I'm starting to host, and we have two other co-hosts, that'd be Doug and Jay. The Carolina GIS coffee break is, we gotta let people in here. Yeah, the goal that we all share here is that this event brings together GIS experts from across the Carolinas. If you are from another state or even another country, feel welcome as well. It's just about sharing ideas about open source, GIS in general, and building a feel for the community and understand what's out there, what the developments are. We got 3 presentations today. And 3 speakers, obviously. Doug Newcomb is one of them. He's going to start. Then Stephen Matter is here from OpenDroneMap, and then we have Randal Hale from River Geographic Systems. No, River Geographic Systems. Yeah, I got that right. So we're going to start with Doug Newcomb. He's a former, where have you been? Hydrologist, IT specialist, and cartographer at the U.S. Department of Interior, now retired, and still very active in the GIS community. And Doug is going to give a presentation about LIS and LAZ. So it's about LiDAR. And the presentation will demonstrate how to visualize, create, convert, and even export point cloud data into raster formats. Doug, go for it.
Well, the create was a little, my brain was going beyond on that one, so we're not going to talk about creation.
Okay, good.
The rest of it will do. Okay. So what's in a point cloud format? We've got LAS. It's a standard out there from ASPRS for point cloud data. LAZ, it's the open industry standard. Been around since 2011. It's under Apache 2 license. You can go to the GitHub site, look it over. It's completely open source. Topic is just an extension of the LAZ format that adds indexing and tiling like the cogs do for rasters. Instead of a cloud-optimized geotiff, we have a cloud-optimized point cloud. ZLAS, that's Esri's undocumented proprietary format. If you have a bunch of that and you want to get it out of that format, you can use the LAS Liberator software, the link I have below, to convert it. Actually, I think by default it takes it to LAZ. So other point cloud formats that are out there, E57 is a pretty generic one. It's like whatever you want to put into it. Autodesk has its own format for point clouds. There's ASCII XYZ. There's a POI format and another ASCII format, PTS-PTX. There's a link there that'll give you the details on each one of those formats. But moving on, let's talk about QGIS and Poodle. Poodle is the point data abstraction library which QGIS uses to read and manage point clouds. It's sort of the second open source point cloud library, the first one being LiveLast, but Howard Butler was of Hobu is pretty much behind both of them. It's a C++ library, and it works with multiple cloud formats, not just LAS and LAZ. PDL Wrench is something that the Python library that the QGIS folks came up with to make things a little bit easier to do cloud processing and to work better inside of QGIS. And it's been part of QGIS since 2023. So this is basically a screenshot of all the point cloud tools in the processing menu for QGIS. You've got tools to do conversion, tools to do management, and extraction. So to convert the format, you can do the format from one point cloud to another format, point cloud, LAS, LAZ, or COPIC, or COPC, sorry. You can convert to raster and vector. You can do TINs. You can do a mean ground with a partial IDW interpolation. Or you can take your points in your point cloud and put them into a geopackaged point vector data set. As far as management, this is where a lot of the heavy lifting is done. You can create virtual point clouds in the same way that people do virtual rasters in Google where you just create a file that points to the point cloud files, but you can treat it like a single point cloud for analysis and processing purposes. You can clip it, you can do a merge, and you can even edit the attributes of the points, not the XYZ coordinates as of yet, but you can change the classification or any of the other attributes of the points, individual points. You can convert the point cloud to a height above ground point cloud, reproject, sign a projection, do ground point classification, which is very essential as a first step. And you can do a point cloud comparison. I've got the URL in there to a blog that Xavier put up today about that, and I advise you to really look through it, because if you're doing any kind of time-based comparison, it is really worthwhile. And you can also do thinning and transforming, like would be rotating and moving the point cloud. And you can also do noise filtering to get low and high noise out of points out of there. And the last bit about extraction is you can do boundary polygons. You can filter your point cloud. So if you just want to have a ground point cloud file, you can just set the filters to ground points and create a new LAZ file. Or you can do a density raster creation, which basically is a raster that's generated, counts the points in each unit. A lot of the times doing a ground point count gives you a good idea of how well things get to the ground. It's not the most perfect way of doing quality assessment on LiDAR collection, but it's a good start. All right, let's switch to the demos. So let's minimize that out, and we've got an empty QGIS desktop. This is QGIS 401. What I'm going to do is I'm going to grab an LAS file from my file browser and just drop it in here. And what you see at the bottom is a percent complete. It's converting the LAS file to a COP-C LAZ file on the fly. And now you see we've got the LAS file, and you've got the points by their classification displayed by default. You can do that, or we can change the layer styling, and we can, instead of looking at classification, we can attribute by ramp, and there's the intensity that we've got there. But you could also do fun things like look at the, where is that? GPS time. There we go. So that's the GPS time. So this was all pretty much taken very closely within, not from different days. You can tell about what time is, and then you can go in and click on the point. And let me see, where is the ID window pop up? Come on. Well, that's interesting. Okay, let's call that a number 1. Oh, I have to actually select it before I do that. All right, there we go. So GPS time, this actually in the identify results, it tells you the exact time converted to a date. So you can see this is done in 2024 on February 5th, Zulu time, which is Greenwich Mean Time. So that's 6 hours ahead of what we're at here. So that actually was done on the 4th of February. But these are all things that you can do very quickly with the COP-C format. So I'm going to remove this now. Okay, and now I'm going to create a virtual point cloud. So we go back, we maximize that up again. Let's go to our point cloud data management, build virtual point cloud. Let's go find our files, add files, and here we go. LAS files. And let's just say that's the input files, and I'm going to put it out to a VPC file. Whoops, there we go. And yes, I did run through this before, so I'm just going to overwrite what I did before. And then just click on run. Come on, I did click on run. I have to wait, the caffeine has to stop. There it goes. So as you can see, it's looking through and listing out all the LAS files that it has. And then what it's creating is a virtual point cloud. Now, I didn't do any of the other options to converted to a COP-Z on the fly, so you're not going to see anything but this boundary right here. But this is very useful, and let's go back and slide down here and pull out our OpenStreetMap. And put it back below so we can actually see what we're doing. Oops. Slow down. All right, you can see this is near the Occoneechee Mountain State Natural Area, just to the south of Hillsborough, North Carolina. And we've got our point cloud here. And what we could do with this virtual point cloud is we could directly convert it to a COP-Z format right here, or we can do an export to raster. So I'm going to do a point cloud to raster. And so I've got the Occoneechee points. Let's set the resolution to 3.125 feet, as that's what we're using. And let's filter it to the classification, include ground and comma, and we go down here to road surfaces because we want this to not have gaps where the roads are. You test that, it says, yay, it likes it. Okay, now let's then click on run. And I made a mistake, but we'll get to that in a second. The mistake I made is that it's going to create an in-memory layer instead of going out to a GeoTIFF, which is only a temporary file. And that you can set it to a permanent file, but I just have to wait a little bit longer, I think. So it's doing tins on pretty much all the points. And I believe it's using about 6.5 million points to do that, which is above the ArcPro 5.2, I think it is, point limit for doing a single area. And in theory, it could be doing a parallel, but I'm not really sure in this case. You can see it knows about the 6 cores and 12 threads I have on this old Xeon laptop. But I don't think it's using quite all of them for the tinning. And that should be about it. All right, there we go. So now we've got a tin, let me close that, a DM that covers all the area right there. And I mentioned that it is the same resolution as the as the state's data set. So let's bring in the TIFF for the state. And just so we can do some quick comparisons, I'm going to go to our layer styling. And instead of a single band gray, we're going to make this hillshade on the fly. Nearest neighbor's cubic to make things look a lot smoother. And then I'm going to copy the style from that. And then I'm going to paste the style to the same. So they're going to look exactly the same when I zoom in. So as you can see right here, this is what the state's database data looks like. And that's what the QGIS version looks like. Just a little bit of difference, not much. And if you notice up here, this was an area that was too small. The River is too small to have 3D break lines, so the tins go across it. And the triangles are at exactly the same place. It's just a little sharper definition. I'm not really sure why, but it's probably a difference in the way the algorithms run between ArcGIS Pro and QGIS. And you could do a similar thing for doing the mean ground. Well, not mean ground with some IDW interpolation. And that would look like there we go. Here it is. I'll just drag and drop one that I did before. So we go ahead and throw that one in there and paste our style into that. Wrong. Okay. Didn't do that right. Let's try that again. All right, so yeah, I don't know why that did that. All right. So anyway, let's move on because I've done something incorrect there. But let's go to our LAZ COP-Z file. So I do have a COP-Z for the whole area. And this is what it would look like as one single point cloud file. Now, one thing that we do like to do is be able to do transects and views. So let's view elevation profile. Let's do a new elevation profile. And so pop that in there, and we'll do it across the top of Occoneechee Mountain. And there we go. You can see the cell tower that's up there. And you can just measure how high the cell tower is. Go up here and go down here to the bottom. And in this case, it's about 90 feet high. We widen that out a little bit so we can change the tolerance to go out a little bit. And if we do that, then we can actually catch the peak of that. Let's pop out a little bit. You can see the other part. And you can see how it compares the trees next to it. You can see the individual boles of the trees in the data. Gives you a good idea of how high resolution this QL1 data is. All right, so let's pop out of that and let's go into 3D. So do 3D map view and pop in that. And if you pop this up, you can see that it's floating above the ground. The reason for that is that you need to set up a raster for the terrain so that it'll be next to each other. So you also see these cube boxes. That's the 3D version of our VPC showing you the outlines in 3D. So if we turn off the Occoneechee points right there, sorry, we got to go back to the 3D one. There it is. There's our 3D map. Okay. All right, so there's our 3D map. And we use this nice little wrench right here to set the terrain to DEM and elevation using the triangulation one that we just created. And I'm going to do a 16 instead of 16. I like 256. Makes things a little sharper. And hit apply, and there we go. Now our terrain is sitting exactly on top of the surface that we generated. That makes like a little bit easier to do visualizations. One other thing I like to do is to do effects and show item lighting, apply that, and that makes things actually look like trees. So let's go in here and zoom in on the road here. And you can see things that are above and below the road a little bit, but you see some gray points that probably could be classified as road points as well. Well, that would be good to classify in that. So let's go back here and make sure that our point cloud is selected there. Then we say, turn on the toggle editing. And I'm going to do classifications instead of create a classification. I'm just going to make road our classification. And then I'll go select by paintbrush. And then I can go through and just start painting some of these gray points right here. And now they're all classifications been changed in them. So now they are actually road points instead of just unclassified. All right. So you can save that, stop, and I'm going to close without saving because I generally don't change things unless I actually have need to. And I think that about uses up all my time. I'm trying to think if there's anything else that I was going to indicate for that? No, I think that pretty much does it. But you can see the cell towers pretty nicely here in this view in 3D. And you could go back and do your prelation. We were measuring that first one, which is only about 90 feet. This one actually turns out to be about 120 feet. All right. So let me get back to area, and I will stop presenting, stop sharing. And yes, turn it over to Steve. Mr. Mather, who is
I might have taken some tips from your thing and added a screenshot. I will not have a live demo, but I liked the lighting effects. So
to introduce Mr. Mather, he is the executive director of the OpenStreetMap. Is it a foundation or
OpenDroneMap? Yeah, it's a nonprofit. Yep.
Oh, okay, all right. And he's been doing this for a while. In fact, he was one of the original coders on this. So take it away, Steve.
Awesome. That was so much fun. I'm gonna have to do more. So I did. It was funny as I was preparing for this. I thought, well, what's the QGIS integration? I'm gonna have to do something special to integrate QGIS. And then I went to my screenshots and realized all of them used QGIS. It's like breathing. You know, it's like the air's there and you forget. So it was really fun, kind of fun to put together. And I did not have a live demo today, but I'll give a little bit on OpenDroneMap sort of background, what you can do with it. Percentage of my screen, I guess. Woo, infinity. I'm spoiling here. There we go. So we'll talk about OpenDroneMap plus QGIS plus grass, because sometimes you just really need to touch grass. By way of background, something that can get you in trouble in North Carolina, South Africa, and a few other places. OpenDroneMap is photogrammetry that you can photogrammetry tool that you can download and start using right now. It's been a fun project. I was the original coder on the project. We've had DK Benjamin stepped in as the second person, and then Pierre Toffanin maintained it for a number of years and has recently departed the project. And we've got a whole team now that are diving in on it, and the future is bright. It's kind of fun. As such, take a bunch of photos, preferably with geolocation data, but my first example won't be. Feed them in. If all goes well, you'll have orthophoto, digital surface model, digital terrain model if you choose that, point cloud, and mesh. And we really strive for it to be both really accessible from the standpoint of not using too many compute resources, and also the aim is that it works regardless. So hopefully it gives you a decent enough product, and then if you want to tune and change things, you can. If I can advance. But my first example is actually of, I don't know if anybody recognizes this young man when he was young and hopeful, but this is Kenneth Kaunda, KK as he's affectionately known, the first president of Zambia. And I was at the National Museum and took a bunch of photos of his of the painting of KK and reconstructed that in 3D. And it turned out rather well. It was kind of a fun little example, sort of the counter example to the geographic examples that we normally see with photogrammetry. But we can scan archives with this, which is one of those interesting use cases that I think is a bit underutilized, because we can really capture a lot of detail and a lot of context with relatively inexpensive tools. So this was literally just my cell phone camera in the museum. With a better camera, it would be even better. Well, let's talk a little bit about that classic geographic space. So this is Boyd Muntengo and OpenDroneMap's own Hubert Samboko, who's the person who leads a lot of our science and research initiatives, and a hydrologist by training and trade. Hubert's I think 2 years out of a PhD now in hydrology. This was part of a project that we did with the EU in doing two things. We essentially captured, well, really three data sets simultaneously. One was a boat on the water with detailed GNSS data, and a fish finder, basically just a small, inexpensive sounding device to capture position and X, Y, and Z of the base of the reservoir. A drone to capture all the dry areas, and of course GNSS on shore to sort of tie everything together. And what we got was a fantastic orthophoto, of course, of Ray's Dam or Ray's Reservoir. If you look down here in the southeast corner, you can see this is where the dam is relative to the rest, and the overflow is right here. We also, a couple of folks were in the field with us, Hessel and Simius and Olivier. I'm blanking on Olivier's surname, but we had 3 hydrologists in the field. So they, of course, hopped out with the best GNS they had and walked to the shore. So we also had a nice little trace of the shore, so we knew exactly where that was at. The nice thing is the secondary things we can get from that. We got the orthophoto, but now we combine the subwater stuff with the dry part of the bathymetry, and now we can start to run scenarios. We know where the maximum water level is based on what the overflow height is, so that's easy to determine. You can see that had we had more time, we would have had to go further north along Ray's Reservoir, and maybe a little bit more northeast here as well. But we were able to fill in the typical water line based on what we knew from the field and from talking to locals about what was happening there. The current water line, as well as that maximum water level for Ray. And then feeding this through, doing the analysis in Q and doing the visualization doing the analysis in GRASS and doing the visualization in combination of GRASS and Q, we're able to create this animation of bank full conditions. But of course, as always, that's tied to quantitative data. So now we can do our depth versus volume and depth versus water area curves. So our stage versus volume and water area, which hydrologists love to see. So that we can actually turn this over to the local management authority and the national management authority and use it for management of the dam over the long term. All with a week in the field, and I won't tell you how long back in the office processing, figuring out how to get this all to work properly. But we can scan all sorts of infrastructure. So not only paintings and reservoirs, but we can do silly things like this is a scan of my house, and I used it to measure the angle of my roof, both relative to ground and relative to north, and use that to actually do some solar predictions. And just to add to that, I really wanted to understand the annual insolation on both sides of my roof, so that I could figure out realistically what kind of outputs I could get. But to take it a level deeper, run a scenario in which the tree in the front yard was full-sized in 20, 30 years at the end of the lifetime of the solar panels. So we can now, essentially, I just dropped a DSM of a tree from the backyard into my front yard, the full-sized version of what we have in the front yard, and then ran the insulation scenarios for that. So now we've got full-size tree and the current situation, which is just a little guy. And cool thing is we were able to see about a 10% annual decrease in solar insolation from that. But nothing significant enough that we really have to worry about that tree getting big and blocking the roof. And the good news is this made a case overall within the household budget to actually get solar installed. And here's a rather auspicious day in May where we produced 91% of our solar, 91% of our electricity. And bonus, I accidentally ended up with 2 electric cars. So this also means we're running the cars off electrons instead of gasoline, which is good news not only for the environment these days, it's good news for the pocketbook. Lots of other scans, scanning of facades of buildings. We can scan, digital objects that perhaps make no sense to this is what is this? This is, give me a second here. It's blue pit crew toad from Mario, from the current Mario racing games on the iPhone, and we were actually able to take video captured from those games and reconstruct them in 3D. And if you ever see me in person, I'm probably wandering around with an actual color 3D print of that blue pit crew toad. I haven't yet printed the orange one. But in the category of more useful things, scans of entire animal enclosures at Cleveland Metro Park Zoo when I worked there, so that we could really analyze and improve animal care and really understand for arboreal species like orangutans, what is, when we make changes to exhibits, how does that inform and change how they interact with those exhibits, and what additional benefits does that provide? And then some examples from the community, from Tomasz out of Poland, and from Mark out of the Netherlands, including some really great shoreline structures that have been scanned over the years. Cool thing is we can do things like storage monitoring, and this is another example from Mark where they have statutory rules about not exceeding 10 meters for storage in certain areas due to flights and other reasons. And in this case, they were able to use scans from drones to establish that they were in fact slightly over those reference points, and they had some work to do to level those out. But I promised to talk a little bit about the future. So we've had some ecosystem changes that have happened. WebODM, which has been our long-term sort of flagship graphical user interface, has left the ecosystem, and we've had some additions. So Drone Tasking Manager has entered the ecosystem. This is a project led by Humanitarian OpenStreetMap team that includes a flight planner and other characteristics that's backed by OpenDroneMap. And then currently we're sort of in this stasis period with OpenDroneMap Desktop, which is strictly speaking a fork of WebODM, but I'll talk a little bit about what that's going to look like short term, and then a little bit, just a little teaser about what we expect to see over the mid and long term. Let's start with Drone TM because that's a little bit more mature at this point. So Drone TM is Drone Tasking Manager, and the idea was that with low cost drones, biggest projects yet have been with DJI Mavic 4 minis. That you could actually do flight planning with them, that you could collect data for whole cities, that you could you could train and task and deploy folks locally to actually do the data collection, and that you could do so in such a way that you could collect the entire city of Freetown, Sierra Leone, for example, 110,000 images, 81 square kilometers, process that into a cohesive data set that could be used by cities for all of their purposes. And that this isn't just a one-time thing, that in the process of making this inexpensive, scalable, and with appropriate capacitation, that you actually repeat this process, that you don't just capture data one time, but you actually have a localized set of organizations managing the collection of this data with a frequency that is sustainable over time. That's a story for another time, but Drone Tasking Manager is one of those world-changing little ideas that it has become sufficiently sophisticated and sufficiently well executed that you should hear a lot of stories about that in the future. With WebODM leaving the ecosystem, we've got a current fork of that is essentially a time stamp in time of WebODM from a few weeks ago. We're currently about to embark on really a library review and dependency ages, apply some interesting security and performance enhancements to the stack so that we can address some of the efficiencies that we see within that context. And then really in the midterm, determine if a full rebuild and replacement is the best option, which is likely. So for now, it's a fork of an existing project, but I expect that in the next few weeks to a few months, we'll have an announcement of something that really kind of goes deeper, a little more native, a little bit more comprehensive, that addresses the special problems that we have as a project where people show up with their images and expect to be able to process them, and we need to be able to accept and inform people in that process. So more as we know it, but that's sort of where that's at. And then I wanted to talk a little bit about sort of the current and the future as far as the developer community. So we can't really claim Jan. He's sort of on a 2-month hiatus from working at various multinational corporations, but he's done a fair bit of volunteer work in his previous hiatus. He spent 6 months after he was done with Meta, and now he's got a couple months that he's spending on OpenSFM in between his prior appointment and whatever's coming next. But he did a whole lot of work within OpenSFM, or back one of our background libraries, in improving GCPs and handling the angles from drones, and ensuring that speed and memory optimizations are absolutely state of the art. Which we're seeing 12x improvements in speed and memory improvements that are of the same order of magnitude. So expect some really exciting things in that space as we get to the point where those changes are being implemented. And to that end, Leonardo Orenia Fuentes, who also has been sort of transitioning between different projects. He finished up in Meta, I think, November or December, and then he's been moving countries and ramping up to become ODM's primary maintainer and an OpenSFM primary maintainer. He spent the last 5 years handling OpenSFM from within Meta, and now that it's an independent project, he'll be our glue tying together that library and our core product. And then Michael Johnson, Leonardo tagged Michael Johnson in really to improve the developer experience. We're a bit in a Voltron phase where we're figuring out how we as a community maintain a project and what that looks like, and what the differences are between that and a predominantly single or maybe 2 developer project where there's a very, very small core team. And the critical part of that from Michael's perspective and sort of the thing that we tasked him with when he first showed up was like, wait, CI/CD better? You actually enjoy doing build processes in CI/CD? Oh, please fix us up. Make it easy. Make it easy to develop on this project. Make it easy for folks to contribute. So he's already well into that, and less than a month into the project. And then we got a couple other folks in the background. Charles Millet has been working on the Windows build of the OpenDroneMap desktop and has been doing some brilliant things there. And then Sachin's tag is Sachin Exists, which is great. He's really looking at how do we improve the security within our build context, and what are the ways in which we can take advantage of ideas that are floating around about how to develop and extend interfaces while still keeping it, really keeping the code development human-centered. So we had him in a few months ago to do some work to rewrite some LLM written stuff in purely human context, so that we don't have to worry about copyright issues and all the other things and ethics issues associated with LLMs. And that work was fantastic, and we're hoping he can continue that work with us within OpenDroneMap desktop. And then within the broader community, we kind of get obsessed about who's the developer and what the developers are, but I just want to give a shout out to Brett, who's been an ongoing, indefatigable member of our community forum, and our various volunteers that are on that forum as well. Brett's a page contributor in that context, but he is just amazing support. He's such a helpful guy in all those contexts. And I mentioned Hubert earlier, tasked with science, but also testing and doing some really, really interesting things, figuring out how best to augment human evaluation of outputs with quantitative tests to highlight where changes may have taken place. So in the context of OpenDroneMap and QGIS, those examples I started with, everything was done. Once it came out of OpenDroneMap, was done in QGIS or GRASS, or a combination of the two generally. And it's really great to follow on with Doug's presentation, because he just showed you how to do point clouds within QGIS, and those apply to photogrammetric point clouds as well as LiDAR point clouds. So we know and expect that orthophotos and digital elevation models should come right out of OpenDroneMap and go right into QGIS. But the incredible functionality that's been added in the last few years by the QGIS team to really enable 3D objects has been fantastic. And point clouds are definitely a first-class object within that ecosystem. Also partially functional are textured meshes. And as I've been starting to finally test those within QGIS, I'll be interested to start to write up some of my findings there, and hopefully that'll help on the performance side for meshes. So whether it's an orthophoto, this one from Muhabura, on the north side of Muhabura and Uganda, whether it's the digital surface model, digital terrain model, or point cloud. Let's get the better looking one from stealing some settings from Doug's presentation. Really, QGIS has created an environment in which the line between those 3D digital assets and traditional two-dimensional GIS is sufficiently blurred that we can get some really, really good work done. For the project itself, ways to support, use OpenDroneMap, please, and reach out, particularly on the forum. We're definitely always looking for volunteers to help with documentation, volunteers to help with code and community. You can download it for free from GitHub. Join the community forum. We've got a fairly active community there that's fantastic. If you have the opportunity to provide monetary support, we still do sell the desktop installer. And with the changes in the ecosystem, we're definitely sorting through how exactly we maintain the financial viability of the project. And we'll be fine, but every little bit helps. And one thing that is super helpful for nonprofit donations in general, if you're not on the desktop installer side, but you want to donate smaller donations that at a level that is easy and maintainable over the long term, really helps with predictability. So that's almost more important. You know, a $500 donation spread out over 2 years is actually far more valuable for an organization because it helps us on the planning side. And then as this world just keeps changing and throwing curveballs to us, if you've got ideas about funding sources and ways to get work done, we're always interested. Hopefully I'm within my time. I know I dunked my phone in the tub yesterday, so I no longer have a clock. But I'm happy to take questions if there's time for it, and if not, I'm happy to pass the presentation on to Randy. It will be highly entertaining. And thank you.
Yeah.
Go ahead, Bernie.
Yeah, great. Thank you, Steve, for the presentation. I pasted the link for the OpenDroneMap donation if anybody wants to consider that. Next up is Randal Hale, and Jay is going to do the introduction.
Thanks for the interesting presentation there, Stephen. Wave of the future kind of stuff. Next up, we've got Randal Hale. He's with River Geographic Systems. Randy is the owner and operator. He's been in the geospatial industry for a long time. He's very involved with OpenDroneMap and QGIS-US. He's been working on a Tennessee 911 project, and I will let him take it away.
Cool. Yeah, I got a story, and I will do it in however much time I need. Somebody just yell, stop. So, yeah, the important thing out of everything is QGIS-US is coming back, which kind of led to this group. These guys have run off on a state level, and I'm trying to get other states to do that. But QGIS-US, we have a US users group now. Yeah, I'd rather be canoeing. News you can use, Phos4G North America, the open source shindig will be happening in Sacramento, California, November 2nd through the 4th. That's kind of it. So here's the story. Way back when, in the early times when Randy had more hair, Randy found himself in the Virgin Islands working on an addressing project. You may wonder, hey, what do I know about addressing? At this point in my life, very, very little. I would still argue I don't know a lot. I know enough to get by, but an addressing expert, I am not, because there's And it's a people problem for me more than anything. But so I was working down there on a 911 addressing project, and it was bizarre. I may have been a Esri business partner at that point, and found myself down there working with all open source tools. And the tool of choice that I was given was I couldn't even make a PDF with it. I couldn't really do much of anything. And then I found this thing called QGIS and kind of fell in love with it because it helped me do a lot of things on the ground. So I would just load this thing on a laptop, go off into the world, and sit at Kmart in the islands, processing data and sending emails and doing a lot of stuff. I can tell you terrible. I had like 2 or 3 presentations on field work in the Caribbean, and it was, to me, more fascinating than anything because, again, I'm sitting at Kmart doing work. So come back, I started dabbling in the open source world more and more, and the QGIS crowd is just they're just a blast. The community is just fun to deal with. It's a lot of smart people. And they really kind of care about the experience, the data, and all the stuff. And for me, everything's a data problem. It just so happens I use this tool to get my data fix in. You can use Pro, you can use whatever you want. But in particular with this, everything I do is kind of open source. So I end up at a conference in 2017 or 2018, I can't remember, in St. Louis. And I ran into Henry County 911, Tennessee. Henry County, Tennessee. They're in Paris, Tennessee. So if you go to Nashville, hang a left, drive about an hour and a half, you will be at a 1/16th scale Eiffel Tower. I should have put a picture of that in there. And what the 911 was doing, they were just kind of getting by. They had a laptop, they had ArcGIS Online, they had 2 copies of ArcView, whatever that's called now, Arc Pro Basic, whatever. Panasonic Toughbook, a file geodatabase, a couple of thumb drives. One person would take the data out in the truck, one person would come back, put another laptop. It was messy, and so they had looked at upgrading, and it was going to be a pile of money for them to upgrade. They were looking probably in the $15,000 to $20,000 worth of software, new server, new everything. It was a bite. It was a hefty amount of work, and so I started talking to him at that point. I'm like, we could maybe do this in QGIS with a geo package or with something, shape files, which led to more discussion, which led to me kind of falling into this 911 thing. So the state of Tennessee has a pretty robust 911 program. The counties all deliver data twice a week to the state. It gets processed. It's up for free if you search like address data Tennessee, you'll find it, and you can download the whole state's worth of addresses, road layer, the whole thing. And so at that point they had 3 layers they were worried about: addresses, roads, and ESN, the Emergency Service Network. And that was kind of it. And so we start talking, and I'm like, there's no reason we can't pull PostGIS into this and just kind of do it. So there were some hiccups, there were some bumps. I mean, when you're basically ripping out one piece of software and inserting another one, it can be a bit trying. And we hit some problems. It was nothing that was too daunting. The great thing was the state had documented everything they wanted in a PDF, so I could crack open the PDF, know that address streets need to be a character 50. I knew everything I needed to know spec-wise to make this work. And so we built a setup. Basically in 2018, I think I changed this 2026, and I should have left it 2018, but the client had a mobile. They were using Fulcrum. They're still using Fulcrum some. We would come in, process the data in QGIS, push it to PostGIS, and then we had a set of scripts that would run and send data to the state and data to their dispatch. So, and if you can't get it to dispatch, nothing good's going to happen. If you can't get to the state, nothing good's going to happen. And so we worked around. Luckily, Dispatch, oh man, it makes me sad. Shape files. Shape files are easy to deal with. So that's what we were delivering to them. To the state at that point, we're delivering a geo package. And because Esri will read a geo package, we were able to work with the state, get them to ingest it. Everything worked. And what became interesting is that the client, who was really, they were not super comfortable with the switch, like they wanted to switch, but once we got everything in place, it just kind of clicked and started working. And they were expecting a lot more pain, I think, at the end of the day. And so the 3 layers grew to 22 layers. They added 19 different layers. They were calling me for months after that going, hey, we found the fire hydrant layer. Can we put it in the database? Hey, we found the bridge layer. Hey, we found the storm shelter layer. We found this, we found that, and we just kept piling it into the database. We started refining the triggers, so they didn't have to collect everything when they went out. Like it's important to get lat and long and X and Y. So the database is in Tennessee State Plane 2274. I'm going to have to update that to the EPSG code 6576, I think. It's the newer one that's coming out, or the newer one that they're doing a lot of data collection in. And so it would just, populate. You drop an address point, it would grab the ESN layer, it would grab lat long, it would grab state plane, it would grab the date that they did the work. When they went out to collect the data, they now have a date. In this case, you see their GPS date was 2008. Previous to this, when they were using ArcView, it was really clunky. And so there was a lot of things they didn't collect that we can now do fairly easily. And, things we couldn't do in 2018. So once we got this installed, in the Esri world, you had network analysts, you had you had, subtypes and domains, and I assume you still have that. I haven't touched Pro in so long. We couldn't export to an Esri file geodatabase. Flash forward 8 years, because this has been running now for 8 straight years. We've been using this setup. We can do drive time analysis. So they were able to start looking at where are the volunteer fire departments, where are the actual, the paid versus volunteer, who's covered, who isn't, in a 5-mile drive analysis. Amazingly, there were a lot of people that weren't covered in a 5 miles. So that helped them start adjusting their insurance. They were adding fire stations. We were able to embed menus, so we could set up drop-down menus to collect data. The state had a hiccup. It got to where the geo package was not working for them at all, and so they gave us a empty file geodatabase, and so we just used the tool set every night to dump the current database in. I think at 2 a.m, it dumps the whole database into an Esri file geodatabase, and they've had no problems now in 3 years, I guess. And we've been updating OpenStreetMap. So I will share out the road layer. Maybe I'll grab it. They don't do the editing. I do it just because I like OpenStreetMap. So we've been updating the roads, buildings, just various things in OSM, which has really come in handy because a lot of their 911 applications are using OSM as a default. So their vehicle tracking software, their radio software, OSM plays a role in it. Things I can't do in 2026, oh my Lord, ask somebody what an address is. It's the front door, it's the center of the house, it's the driveway, and you can literally go from one county to the next, and everybody does it differently, which has made kind of automated addressing a little bit of a pain. I'm getting closer to getting that to work. People wanting to roll out old equipment. Somebody will drag an 8-year-old server out of the closet and go, can we use this? And I used to say yes enthusiastically because we had a Linux backend, we had PostGIS. It didn't really matter. We could run it on Windows. Operating system agnostic. It doesn't matter. I really want to get away from that because, man, it's just, it's awful when you're using that old of equipment. We don't need backups. I hear that more than I care to admit. We don't want to back up anything. That's just extra work. No, you're going to need backups. Getting people to trust their data. A lot of people still don't. And really, it's up to you to make good data. So getting people to, make the data good and not just go out and use your phone to collect a GPS. Maybe get a better GPS unit. Do something to get better data. Getting people to agree on the cloud. I think at this point, moving forward, I'm forcing everybody into the cloud because I want to do backups. We need decent equipment. Cloud computing, AWS makes me tired, but there's a lot of different offers. There's a lot of different things you can go with out there. And so we've been using for another project, DigitalOcean. Do backups, whatever you want to do, it works great. Drive time analysis. I call this unintended joy because this is a tool set that just comes with QGIS and you play around with it, and everything in green was within 5 miles. Dark green, everything in light green everything in dark green was 2 miles away from a fire station. Everything in light green was 5 miles away. Everything in red, not covered. You couldn't get there quick enough. And it was really interesting where these areas were at. And in this case, Paris is downtown, and you had really just right outside of Paris, you had an area that wasn't covered. So they've adjusted and fixed that. And again, going back to the GeoPackage, we set up a script to run every night. I'm a programmer, I am not, but this was fairly easy to do. It dumps the database out, dumps it in the file in the Esri file format. Rapid SOS is a group that lets you call 911 from your cell phone and then tell it exactly where you're at. And they called and said, we don't want none of that hippie open source software. Don't work. It doesn't work. We need it out of Pro. And so I just went back to QGIS and dumped an Esri file geodatabase and sent it to them. They said, man, that's amazing. It looks great. And I went, cool. You'll never know what I just did. And so every month they get an update now. And the nice thing is nobody knows. Nobody really cares because we've got good data out of this. Menus have been kind of fun. It's been interesting to try to make things easier. And what I have found is that after the initial setup, people get kind of hung up and they don't want it easier. And so I've been having a little bit of a little bit of pain trying to get things, introducing new menus and new setups to this. And this menu took all the things they didn't need to worry about out of the equation and all the stuff that they could do. Like, it was really hard to do structure type. You had a 100-row spreadsheet of every structure in a county, and now it's just 2 menu picks and you're good. It's really quick. Mobile. QGIS has 2 mobile options, QField and Mergin. Disclaimer, I'm in Mergin Maps business partner. So another county adopted this setup. We're running all theirs on Windows, but they're using Mergin to go out, collect data, syncing it back into QGIS, syncing it back to the server. So it's a little bit clunky. We've got to work out a better way. And in fact, they called me this morning. Can we make it easier? And we probably can. And the OpenStreetMap updates that I mentioned earlier. Tennessee has a building footprint layer, so I just may have just pushed the building footprint layer into the county, fixed the roads, fixed naming, fixed a lot of things that were wrong with the OpenStreetMap layer. So it has helped because Amazon, Facebook, Amazon uses it for deliveries. I think TomTom has been ingesting it, and so they have seen fewer and fewer problems as life goes on. And yeah, they're sending it to Google, but I let them worry about that. I'm more worried with OpenStreetMap stuff. LiDAR. The 911 couldn't view their LiDAR data. All the counties in Tennessee get new LiDAR every 4 years. They didn't have the software to view it. They can now view it, measure building height, do whatever they want. Play around with drones. They've got an active drone program in this county, and this kind of helps them out a little bit. They can look at stuff. And what was really funny out of this whole thing, so I got a little bit panicky, which is another long story, last year, and I shoved everything I did into GitHub. So if you get on GitHub, you look at North River Geo, you'll see a Tennessee NG911, and it's got all the setup scripts, all the stuff. It works great for Tennessee. If North Carolina, you might be able to get some ideas from it. I've carried those ideas over into the Oklahoma 911. So what I discovered in all of this is that NINA, the 911 standard, is built as an Esri file geodatabase and in PostgreSQL. So they are acknowledging the open source realm, where you can go in and build your own NINA standard horrendously. I mean, it's got a lot of stuff in it. It's not refined to a certain state. It's just the national. But it does have an open source component to it, which is kind of nice. And I was able to collectively learn a little bit from there, maybe steal it, on some of their data checks and other things they were doing, and incorporate that into the Tennessee work. So going forward, much like Stephen was talking about, where does it stand? I work on this when I get time, when I get funding. It's just me. It's a couple of clients now. I think I may have another client coming on board. So what's going to happen next? SQL data checks. We're going to check the data like crazy moving forward. To give you an idea, I may end up doing this in Python. I honestly don't know. You can run some SQL code and compare what your address street name is versus your centerline street name. Amazingly enough, in Tennessee, we don't check that. So you'll have a main M-A-I-N, a main M-I-A-N misspelled, doesn't get caught. This will catch it. The other thing is, how many Van Dykes do we need in a county? Van Dyke Cemetery, Van Dyke Grove, Van Dyke Loop, Van Dyke Road. In Hamilton, they went through and tried to remove that. So you can't call 911 and go, I'm on Van Dyke. Which one? There's 4 of them. They've kind of fixed that here in this county. And others not so much, but these scripts will run. Again, I'm trying to make it easier for them to run the scripts. I've just got to figure out a good way to do that. But in QGIS, you can run SQL against the database, and everybody's happy, and life is good. And, scroll in, scroll out, do whatever you want to do. It just makes things so much easier. Again, publish everything on GitHub. I'm still updating stuff. I'm still figuring out different ways to do things. I've got the install of the database down to about a minute. So I think in less than a day, I can take the Tennessee data and migrate it out of your current commercial stack into this, and it works. And I want to do a web map. I am not that good at web maps, and I started learning Leaflet a couple of years ago. Map Libre entices me. I don't know enough about it, so I've been learning a little bit, but possibly having a web map you can just spin up and then you've got one. And more QGIS customizations. I would like to do a plugin. I've said I want to do a plugin for a while. Been experimenting, but not that great at it. But things get better every year. So this has gotten way better than it was in 2018. It's a whole different beast now. It used to take me half a day to get it set up. Now I'm down to maybe a minute, maybe 2 minutes. So, and other than that, that's it. I got through it. I'm a little bit over, but not bad. Angst, questions, fear, anger.
Yeah, fantastic. Thank you, Randall, and thanks, Stephen and Doug, for presenting today. We'll have another webinar possibly coming up in June. And Doug, what about the in-person, like small conference maybe? In September, was that right? Or was it August?
Yeah, I think do we have a location yet for that?
Not yet, working on it. Okay. But yeah, we'll keep you posted. So the next one is definitely probably late June, another webinar, maybe beginning of July, depending on what people's schedules are looking like.
I did want to add one thing to my presentation I forgot, is that when you do the compression to LAZ, it takes the file size down to about 20 to 25%. of the LAS file size. So when you're talking, terabytes of data, it can give you some real storage savings. And it's faster because the data being compressed, it takes less time to come off the storage media via hard drive or SSD. Sorry, didn't mean to interrupt your wrap up.
Yeah, good to know. And all that happened in QGIS-4, which is the new version of QGIS, right? And
there was some stuff in 3.2.3 on, but QGIS-4 really is bringing a lot of good new stuff to the table.
right, it's good to hear. All right, thanks everybody for joining, especially the ones that were listening in. And it wouldn't be a good coffee break without you. So spread the word and join us next time when we meet. It's always good to have you. And thanks again to all the presenters. I appreciate you coming out today and sacrifice your lunchtime. It's always good to have someone contributing to the open source world. And with that, I'll let you go. Have a good rest of the week and enjoy the rest of your day. Thanks, guys.